What are prime numbers? What are prime numbers? Yes, I want to hear from you.
Prime number is that has factors.
Okay. Yes. Okay, only two positive part, one and itself. That's good. That's good. No, it's good. So it would have been good to instead of saying positive numbers, maybe say it's integers. Integers are not just numbers, right? You see this these prime numbers. We didn't say prime integers. Prime numbers are integers. All prime numbers are integers. The same thing, all whole number, sorry, all even numbers. See, we're not saying even integers, but when we say even numbers, we already know that they are integers. So prime numbers are positive integers, okay? And then you can add what we said. Or sometimes it might also make it clearer by saying positive integers greater than 1. Okay, that has two factors, only two factors. Okay, thank you so much. Yes, we can just take your definition. Okay, so this side we can just be thinking about the the defining lines. So that is a positive integers. They are greater than 1. Two factors. 1, 1 and the prime, and all and all and all. So the prime numbers is used for several things, but one thing I want us to do now, which we are also going to practice, is prime factorization. Prime factorization. No, when I was saying, asking you, I say, oh, prime factorization. Now say, you have mentioned prime numbers and you have mentioned factorization. Prime factorization. If you ask me, if you just put it in a very easy way, it is writing a number in terms of prime numbers. A number that is not a prime, but you write it in terms of prime numbers. Is 10 a prime number? Are you here? Is 10 a prime number?
That's not a prime number.
Okay. 10 is not a prime number. Is 2 times 5 the same thing as 10? 10 is 2 times 5. Both 2 and 5 are prime numbers. So the prime factorization of 10 is 2 times 5. And from here, you can easily get the prime factorization of 100, which is 100 is 10 squared, which will now be, I will also be using this small to teach you exponents. Like, let's say 2 times 5 is 10, then square. You know that if we put this square where we have it now, it's also the same thing as 2 squared times 5 squared, right? You know why that is important. It's important to know that you are going to expand, you are going to expand the full you are going to expand the full bracket. Look at this. 2 times 5 times 2. 2 times 5 times 2. I'm asking you, 2 times 5 times 2.
Times 5 that's 20.
Now I want to show you something. If you have 2 times 5, then times 2. If you open it, you are going to multiply to only 1, not 2. So this times 2 outside can only distribute just with only 1, not all of them. So it's going to be 2 times 5 times 2, 10. You see that is 20. Or you can also decide to use the other one. So you can also decide to use the other one. I'm going to show you what I mean by the other one. This is also true if you take the 2 to 4. 2 times 2, which is 4, times 5, is also equal to 20. But if you do it to, if it is a square, you are not going to say 2 times, you only square 5. You are going to square everything. All right. So gradually you will know simple rules. And you also said you also had you mentioning about simple addition subtraction. So you learn the rules. So the prime factorization of 100 is 2 squared times 5 squared. Can you call a number you like? Must be at least 2-digit number. Let's find the prime factorization. Once we are done with that, we'll move on. We'll start adding other things. But 64 is a little more straightforward. Okay, I don't know whether you can come up with another number. 64 is a little more straightforward, and you know why? And in that straightforward of 64, because look at 64. The prime number, the 64 is equals to 2 raised to the power, that's 6. 2 raised to the power 6 is the prime factorization of 64. Can you do it? Okay. Okay. Is what?
Sorry, sir. Okay. Now come on that 100 100 100 and 4 and then therefore we have that we have 10 5. So I'll now count the number of integers. 1 2 5 power 5 raised to power 5 raised to power 1 5 raised to power 3. I don't know.
Let's first of all check whether it's correct. Remember, 2 raised to the power 7 is what?
Sorry, that was 100 power 6 power 100 power 6 5 raised to power 5 raised to power 2.
Okay, 5 raised to the power 3.
5 raised to power 2.
5 raised to the power 3 or 2? Okay, what we have said here now, if we implement it, is going to be 2 raised to the power 6, right? Is what? Can you work it out? Can you work out 2 raised to the power 6?
Power 4.
So 64 times 25. Can you confirm whether it's 2000?
I'm trying to calculate.
If you are solving question, one thing that you're supposed to do, is to pay attention, right? You pay attention, right? Right now we already have 2 by 5, right? We already have 2 by 5. We already have 2 by we already have 100 as 2 times 5. 2 raised to the power 2 times 5 raised to the power 2. You could have just continued from there. I mean, it will have made sense. Yeah, it will have made sense. It will have been much easier. You could have arrived at the answer faster. Have continued from there. Because take it this way. So you have 100 already as 2 raised to the power 2 times 2 raised to the power 5. You already have this. But you ask yourself, so let me ask you, what do you multiply with 100 to give 2000? What do you multiply with 100 to get 2000? 1000. I mean 1000. Remember, you have, okay, sorry, we have 100. So what do you multiply with 100 to get 2000? So you see that it is just 20. Yeah, if you multiply it, if you multiply it with 20, to give you. Now, I mean, because we already have it, we already, we did it already. So if we just multiply this by 20, okay, it will give you 1000. That is 1000. 1000 is this. Because 1000 is this, I can now make 20. So this is 20 is 2 times 2 times 5. So I'm introducing only 2 or twice. 2 times 2 times 5. 2 times 2 times 5 is 2 times 2 times 5 will give me 2 times 2 times 5 will give me 20. So those 2 times 2, I'll bring the 2 here. So it'll be 2 squared times 4. That is 5. Oh, just because of want of space. But okay, so let me reduce my writing. So 2 times 2 times 2 raised to the power 5. 20 is times 2 times 5. So I now have 2 raised to the power 2 times 2 raised to the power 2, which is 2 raised to the power 4, by 2 raised oh, my mistake. Oh, this is, see, now I turned this upside down. So this is rather 5 raised to the power 2. 5 raised to the power 2. So this 5 raised to the power 2. So this is 5. Oh, I even continue the same thing here. This is 5 raised to the power 2. 5 raised to the power 2 times 5 is 5 raised to the power 3. So that is based on what you already know, or based on what you already have now. Depending on what you have built, so where you are already. 2 raised to the power 4 times 5 raised to the power 3. This is also the same thing, but I'm only saying that maybe it could have been much faster. Okay, so let's move on now. So let's move on. All the things you can do with prime factorization, one of them comes very handy, very prominent, and it is the use of prime numbers. So the use of prime numbers find numbers of factors. So let's quickly do it. Number of factors. First, positive factors. To see 12, how many factors? 12 is, the factors of 12 are 1, 12. One good way of doing it, we have 2 and 6. Then we have 3 and 4. That is how many factors? How many factors? Are you here with me?
Yes, sir.
1, 2, 3, 4, 6, and 12. How many factors?
That's 6.
All right, that is 6 factors. 6 factors. Now, this is how many factors. If you want to apply this, the prime factorization of 12 is 4 times 3. Sorry, 2 raised to the power 2. 2 raised to the power 2 times 3. 2 raised to the power 2 times 3 is 12. So this is the prime factorization of 12. Now, let's call this, but this is 3 raised to the power 1. Let's say if we rewrite this as 12 equals 2 raised to the power a times 3 raised to the power b times 5 raised to the power c times the next prime number is 7 raised to the power d down to infinity. Then the number of factors equals a plus 1 times b plus 1 times c plus 1 till you add all of them. Yeah, right. You multiply them down to the last one. Now, using this 12 again as an example, if you want to set this 12, what we have is 2 raised to the power 2 times 3 raised to the power 1 times 5 raised to the power 0 times 7 raised to the power 0, because 5, 7, they are not there. And remember, you told me you revise exponents. Anything raised to the power of 0, if you raise a number to the power of 0, it becomes what?
0.
It becomes 1. Let me quickly demonstrate that for you. I'm going to ask you, if we have a raised to the power s times a raised to the power y, this becomes what?
Power x.
Are you sure you did exponents? This will become a raised to the power s plus y. Are you there?
Yeah.
Okay, so let's take a pause. Let's bring up the formula sheet, the one I shared with you, whether you will have been able to know this if you have gone through it. Yeah, so here is the exponent. So you can see the rules. When we multiply together, if we multiply out, multiply, we add, division, we divide with a minus b. So it is also here, is from here. If you pay attention, okay, you also see that one, this one, s raised to the power a comma b, the same thing as s raised to the power ab. Yeah, we used it earlier today. I think either the 8 a.m. or the 10 a.m. All right. See the one that concerns us now. Once you raise any number raised to the power, look at this very well. Look at this division of like bases. Take 30 seconds or a minute to look at it. Okay, now tell me the answer of this one. A raised to the power y divided by a raised to the power z is equals to what?
A raised to the power y
minus z. A raised to the power 3 divided by a raised to the power 2 is equal to
A raised to the power.
But we also know that a raised to the power 3 divided by a raised to the power 3 is also equal to 1. Do you agree? That yes, it had. But when we put it in indices, we end up having 3 minus 3 equals a raised to the power 0. That is to say that that which you see that had turned to become something raised to the power 0 was a division. Is a number that is dividing itself. So that from there we say anything raised to the power 0 equals 1. Is that okay? Have you, is that settled with you?
Yeah.
Okay. Okay, so now let's go back to the prime factorization. So sometimes in mathematics, we do manipulation. So when we are saying 5 raised to the power 0, 7 raised to the power 0, it's as good as they are not there, right? Because they are just 5 raised to the power 0 is 1. So anything times 1 is still the same. Okay, so let's get this. So in solving 12 equals 2 raised to the power 2 times 3 raised to the power 1, A is 2. Number of factors. A is 2, or maybe we can write it full, in full. 2 plus 1, then B plus 1. Of course, it's only 2 of them, so we can actually stop here. So we are going to have 2 2 plus 1 bracket 1 plus 1 equals 3 times 2 equals 6. Remember, those are the 6 factors we counted before. Remember when we counted it? 1, 2, 3, 4, 5, 6. Let's say 10, or let's say 15. Of course, 15 is just 3 by 5. The prime factorization of 15. And if we do it, number of factors, remember that is 3, 1 times 5 raised to the power 1. Number of factors equals 3, sorry, not 3, 1 plus 1 into 1 plus 1. That is equals to 2 times 2, 4. That is why if we list factors of 15, you have 1, 3, 5, and 15. That is 4 factors. So this is one application of prime factorization. Look at the formula there. Up here, where we wrote 12 equals 2 raised to the power 2 times 3 raised to the power 1. And we said number of factors is A plus 1 bracket B plus 1. Right? So in this case, A is 2. Or you need to start looking where we introduce it the first time. Number of factors. See that A plus 1, B plus 1, C plus 1. And what is this A? You see again, with the example of 12, 12 is 2 raised to the power 3 times 3 raised to the power 1, which we can also say that these powers, let's identify these powers with A, B, C, D. All right, so coming back here, what we can do is to use another example. You see, 15 is 3 raised to the power 1 times 5 raised to the power 1. So A is 1, B is 1. So in A plus 1, B plus 1, so 1 plus 1, 1 plus 1, and then 1 plus 1, and 1 plus 1. 2 times 2 is 4. So let's use a different number. Let's say 18. First, let's find all the factors of 18. Then apply prime factorization and use it to find the number of factors. Call the factors of 18 for me.
5,
Okay. 3, 6. Okay. 9. How many of them? What is the prime factorization?
Power 1. Power
Can be 2 raised to the power 2. If you are saying 2 raised to the power 2, that means it's 4. That means you are getting 4. And 4 is 4 a factor of 18. No?
okay. That's the power 1.
2 raised to the power 1 times what?
Power
3 raised to the power 2. So if we go to number of factors now, a plus 1 into a into b plus 1. What is a?
1.
So that is 1 plus 1. B is what? So that is 2 plus 1. And 2 times 3 is. So that is the number of factors. So how to get so that's because for us how to get number of factors. All right, so that should be all for number of factors now. But let's start now answering some other questions. The questions the build up today's prime factorization. Before you talk about prime factorization, we have talked about even numbers, odd numbers, because positive even numbers and positive odd and yes, positive odd numbers and even number. So it's odd numbers and the even number too that made up prime numbers. So let's look at this question. Which of the following numbers is a divisor of 36 and a multiple of 4? If you ask me what this question is testing, not just testing this question, right? Question is not just testing your ability, whether you can solve it or not. Okay, the question is also testing how fast you do it. Yeah, let's do it. Can you do it now? Fast. 3 is not there because 3 is not 3 is and a multiple of 4, so 3 is not a multiple of 4, so you move on. How about 4? How about 8? Be fast. 4 is there. Okay,
Okay.
okay, so you just start with 4. 4 is there. Okay, is 3 there? Okay, 4 is there. How about 8? 8 is not there.
Okay. 9.
Why is 9 there?
Oh, sorry. 9.
Okay, what else?
Oh,
Okay, what else? Then 36. Okay, I hope they show the solution. Oh yeah, so we have 4, 12, and 36. Okay, so we have prime factor. I think we have talked all about this. I've already talked about this. Let's see. Is this the question? Let's walk through an example factoring. Given 13x times 11y equals 1430. Which of the following is the value of s over y if both variables are greater than if both variables are greater than 1 and s is greater than y, okay, and s is greater than y, okay, and s is greater than y. As usual, I like these sites. I think this is the first time of opening it. They didn't we need to solve before we see an answer. Okay, so it's your turn to try the question. Once you see a question like this one, start thinking, wow, what can this be? What can this be? What can this be? Right? Is that thinking is the is the main thing, right? Is the main thing. We say, I don't know. Will you bring us that? Bring us. Oh, it have brought it. Super. Okay, so when you see this, start thinking, and say, wow. From one prime factorization, what can I get this? Since I have 13s and I have 11y equals 14 times 30, right? It could actually mean that both 13 and 11 can divide 1430. So this is what's the first thing. Honestly, I've not solved this problem. I've not seen this question all my life. So I have trained myself to see question. It's not the actual thing you learn. So, oh, I left no fraction. I know this. No, those are building block that will now give your brain a way to think. Of like this morning, it rained heavily here in Lagos. In this part, it rained heavily. Okay, now raining heavily. The rain of this today might be different from all the other rains, but they are still rain. So you are not bothered. So you have a way so we have a way of acting when it rains. So that is how the GRE is supposed to be. But if you say if it's going to rain heavily, what do you mean? Like what? Okay, if it's going to rain at 2 p.m. so what will I do? Somebody will tell you, okay, if it's rain at 2 p.m. do this, and you come back and say, what if it rain at 3 p.m. You see that we don't ask that type of question. What we need is a basic idea of what to do should it rain. So looking at this question, don't you see that since if you multiply these things, it will give you 1430. One thing that you can do first is check whether you can divide through this number. Is it that number is 143? Okay, can 143 can if you give me this number and I want to find out if 13 can divide 143, right? If I want to find out whether 13 can divide 143, I can already see that 11 can divide it. Yeah. You know that 11 can divide 143, right? How do you know? No, if you are saying 143, calculator apart. Calculator is the additional thing you are building. The calculator is what you are adding to what you have. It's a capability. It's something enhancing your capability. But if you look at 1430, how do you know that is 11 can divide it? For me, through the divisibility rule, because it's very handy. A number is divisible by 11. If you add them together, look at it. You can go back and check this divisibility rule. If you write 1430, the rule is if you add all the first numbers are like 1, 2, 1, 2. You add all the ones together. You add all the twos together. 1 plus 3 is 4 minus 4 plus 0 is 4. If you add all the ones together, all the twos together and subtract, 4 minus 4 is 0. In as much as 11 can divide 0, then 11 can still divide this number. But now, how about for 169? I must not do the same thing all the time. That is in the stories of strategy. That is a man, the ancient Japanese swordman. I don't want to bite my tongue pronouncing it, but just type ancient Japanese swordman. You say you will see him. So one thing he brought to warfare is that each combat is approaching it a little differently, right? So you keep your strategy on flow. Let flow be your strategy. It's not static. If I want to do for 169, sorry, 143, can 13 divide 143? Okay, there are several ways you can do it, including reaching out with to your calculator. But I'm asking, what if there is no calculator? If there is some other ways, right, you can do this. You'll have noticed then, something like this. You'll have noticed, what is 13 times 13? Thirteen times 13 is 169. Why I'm asking you 13 times 13? I want to know whether you know that one, because everything is based on resources. I've often referred to the Iranian-US war in my recent classes, because it's about resources. It's about resources. If you already know that 13 times 13, if you already know what is 13 times 13 is 169, then it will be easier for you to know from 143. So because if you already know that 13 times 13, because 13 times 13 is a number you can know as 169. So you can easily remove 13, 2 of it here, 20, that is 26. 9 minus 6 is 3. 6 minus 2 is 4. Then 142. So it's okay. 13 can divide this number. So 13 can divide this stuff, right? 11 can divide it. 13 can divide it. And I know that 11 times 11 is 121. 121 plus 11. 121 plus 11. Okay, have you been following me? 13 times 13 is 169. Okay. 169 minus, yes, 169 minus 26 is 143. Fine. 11 times 11. What? Yeah, so this is also another thing that I'm saying, okay? Because 11 times 11 is 121. It's not really. It's having a lot of things you are going to do without calculator. A lot of things you can do without calculator will help you to move faster, to navigate things faster. Okay. You'll notice that if you add 211 to 121, 2 11s is what? 121 plus 22 is 143, right? So it means that this number here, this 143 is 11 times 13 is 143, then times 10. Are you there? We have.
So what did you give me?
Hey, you kill me, oh. You buy another coffee for me, oh. No, see, I want you to process information fast, and I'm not insulting you. The 11 times 13. I thought we just say it now. Even there, 11 times 13.
It's 143.
Has
143.
143. So this is 13 times 11. 13 times 11 is 143. Okay, so we have arrived. I'm only showing you. I'm trying to show you something that is very, very hard, right? My own thinking process. I'm just telling you, if I see this question, how my mind is connecting things. So my mind is connecting a lot of things. It's not one thing. It's connecting many things, right? Or not only. So it's not one direct thing to do. So if I the one solving this question, my mind is connecting, connect this, connect that, is connect. But that's how to solve questions. Now how to solve it faster. Yes. All right. So this is 143. Okay. 143 times 10. That is what we are looking for. So that is times 10. Now the question added more things. It said if both variables are greater than 1, if both variables are greater than 1 and s is greater than y, s is greater than y, so what is s over y? Can you now solve it? So the people that said this question also made a mistake, right? This question is not thorough, right? It's not thorough. I'm going to explain that for you, but for now, just assume that s and y are both integers. Are you there? Okay, so can you finish it up now? What is s? What is y? 11 times 10 or 13 times 10 is 143. So what we have added is 10. What is s? What is y? And that s is greater than y is what? Are you there?
X is and Y is
Yeah, you are definitely hungry. You didn't take your breakfast. Uh there's nothing to reason again. See, 11 times 13 is 143. What we are looking for is 10, 10, because 10 and 13 and 11 are there. So they are there already, times 10. So is this times 10? What could be two components, two numbers you can multiply to get 10?
5.
So it's 2 and 5. And because they said one is greater than the other, they say that if both variables are greater than 1 and s is greater than y, which of the following is the value of s over y? But if you go to the exam, they ask you this question without knowing anything to solve. Which of these options will you eliminate first? Option A, B, C, D, and E. Which of them? S is greater than y. It depends on how you are processing. You can quickly scan through numbers that are greater than the other. If the numerator is greater than the denominator, the result cannot be 0 points. True or false? Are you there? If the numerator is greater than the denominator, the result cannot be 0 points. So these two options will not be correct. Since we are looking for 10 and one of the number and one of the the numbers and if both variables are greater than 1 and both variables are greater than 1, so if both variables are greater than 1 and we are looking for 10, so we are looking for two numbers to multiply to get 10. Apart from 2 times 5, which other numbers can you multiply to get 10? 1 and 10. But the numbers are greater than 1. So that means 1 and 10 will not work. So this one is out too. Four times 2.5. 4 times 2.5. Yes, 4 times 2.5. Yes, I'm just trying to let you know that there are also other numbers. You know, when you go to exam like this and they say number without defining what type of number they are in. Both integers, whole numbers, all of them are all included. So it means but 4 and 2.5. But what they're asking is if both variables are greater than this, which of the following is the value of s over y? So another number that here that can give us 10 is 2 and 5, right? 5 over 2. 5 over 2.
0.5.
That is 2.5. Okay, so that is 2.5. All right, 2.5. Try solving it. So the answer is 2.5. We got it. So you can have a process you can trust. All right, let's go. We have few minutes. What we are going to do now is try practicing. But I'm going to share this site too. I think I'm going to share it. If you want to check more. But I don't know. I don't know how it is entirely. Let me see. Let me see that particular site. Let me open it now and share. Of course, for that purpose, not that we are selling their sites. Okay, so I am going to share this. I'm going to send it. I'm going to send it direct. I'm going to the group. Why is it not sharing? Our time. Okay. Just send it to the group so you can access it. What I want you to do, what I want us to do. Oh, I think you can practically do prime factorization. Hello?
Yeah.
Do you need to practice prime factorization? I don't think. You can practically get prime factorization correctly.
But I cannot do that.
Okay.
I will practice on my own.
Okay, you can practice on your own. Or then I said just generally you can go to Khan Academy and practice. Write prime factorization. Start practicing. memorize this. Okay. We have solved this one. 9 dice. Remainders, remainder is not a very big deal. It's about that is all. There are no question. They didn't ask a question. Okay, look at this one. The question. Compare quantity A to quantity B. Yes. First, what is a remainder? A remainder is what remains. I need the remainder of the money. Give me the remainder. Just ask somebody, did you spend all the money? Say no. Can you send me the remainder? That is just, is in that sense. Remainder is what remain, right? And in the other book we use, the problem solving, that is an interesting question there that said if n is a prime number greater than 3, what is the remainder when n squared is divided by 12? I don't think we get up to there now. I don't think we can get to that now. But now try this question. Try it. The question is compare quantity A and quantity B. Quantity A, so the question is, let's try, okay, another example. Okay, here. Quantity A is twice the remainder of 198 divided by 12, and quantity B is 3 times the remainder of 175 divided by 4. Hold on, let's talk a little more about remainders. Let me ask you, 5 divided by 3, what is the remainder?
Sorry, sir, can you come again?
5 divided by 3, what is the remainder?
5 divided by 1 over 2. 1.
1 is the remainder, or what?
Remainder is like 1.5. 1.
Are you sure you are listening to me? I said the remainder is what remains. And I now gave you example of, let's say you send someone to run errand or do something for you, or you are monitoring a project. After, at the end of the project, you call and say, is there any money remaining? They say yes. And you say, can you send me the remainder? The remainder is what remains. What is remaining is the remainder. It's not, yes, they're not asking you to find decimal. Nobody's asking you to find decimal. Okay. Yes, they're asking you to find the remainder, not the decimal. So what is the remainder? So the remainder is 2. So this equals 2. Okay? And how we normally write it is 1 whole number 2 over 3. Okay, so what is the remainder? 3 over 5. What is the remainder? If we have, I've turned it upside down. If you have 3 over 5, what is the remainder? Yes, there is always a temptation to think that is 0. Yeah, but it's not 0. Okay, you see? So it looks like 0, but it's not 0. The remainder when 3 is divided by 5 is 3. 5 people want to divide 3 things. They couldn't divide it. They go back, they went back, and the 3 is still remaining. And the idea of remainder is also because of things that we cannot put in fraction. So the remainder when 3 is divided by 5 is 3. So the remainder equals 0 whole number remainder 3. Just like this one is 1 whole number remainder 2. So this one is 0 whole number remainder 3. Yeah, I'm trying to avoid complex formulas, so that now you just go and say, I know the formula for remainder. No, just take it just on the basic understanding of it, and the remainder is what is remaining. Compare quantity A to quantity B. So compare quantity A to quantity B. Why is the remainder of 198 divided by 12? 198 divided by 12. What is the remainder? With calculator, how will you quickly do it? How will you quickly do this? How do you quickly do this? Let's do it together. As let me say you want to quickly find this. So you want to quickly find this. Okay, want to quickly find this. Oh, yeah. So if you want to quickly find this, so what will you do? As many if you have calculator, want to use calculator. 198 divided by 12. Can you get it? 16 point something. Okay, 16 times 12. Okay, 196 divided by 12 is what?
Uh,
16 whole number 4 over. Okay. What of the other one? That is the remainder here is 4, right? So we know that the remainder also the remainder is 4. Remember, okay. The other one, twice the remainder. So the remainder and 2r equals 8. That not? Let's do the other one.
okay, that one.
So the remainder here is 3. Okay. 2 okay. Oh yeah. It's not what he's saying.
3.
Yes, 3R. So which one is greater, quantity A or quantity B? Okay. Wow, he's saying that quantity A is greater.
Why did they times
6 times what?
4?
I don't know. We can rather reevaluate what you gave. You said I do know that 96
Oh,
nine.
sorry, that's not. But that's not. But what I did was 190.
So you have given me fake number, right?
Sorry, that. I just said.
Okay, so we are going to have 6 and we have 6 and is 12. So quantity A is now greater. Okay, all right. So the working is correct, only that. Oh, okay. Yeah. All right. So that will be all for now. The one session. Want to kill son of man.
Okay.
Okay, bye.
Thank you. Bye.